This video is to prove Theorem 3.10, which says suppose A and B are 2 by 2 matrices with real coefficients, then R sub A composed of R sub B should be equal to R sub AB. So first of all, let A be A, B, C, D, 2 by 2 matrices. Let B be alpha, beta, gamma, delta. That's not how you write delta. Delta. Okay, so if A is that matrices, then R of A is AX plus B over CX plus D. Therefore, R sub D will be alpha X plus beta over gamma X plus beta. So let's just look at the left side of it. Left side of it says R sub A composed of R sub B of X, which means R sub A of R sub B of X. So R sub B of X is this guy, which is alpha X plus beta all over gamma X plus beta. So we're going to replace that. Then we'll have R sub A times alpha X plus beta all over gamma X plus, sorry, this is delta. Okay? And as you remember, if you have f of g of x, for example, and if g of x is 2x, and let's say if f of x is x squared, then you do 2 of x first, right? So you're going to put it in f of g of x, which is 2x. What are you going to do with the 2x? You're going to plug in here. So you're going to have the f of 2 of x will be 2x to the second power, right? So we're going to do the same thing here. So we're going to plug this in, alpha x plus beta all over gamma x plus delta for x for the R sub A. So we'll have A times the big guy plus B, which is alpha x plus beta all over gamma x plus delta, all over C times the same guy plus D. And then if you just look at the numerator part, if you multiply it, you get A times alpha x plus beta over gamma x plus delta plus B all over C times alpha x plus beta over gamma x plus delta plus D. Whew. Then we'll have, the numerator will have A times alpha x plus beta, you see the common denominator, right, is going to be gamma x plus delta. So we'll have B times the same guy, which is gamma x plus delta, all over the same thing, C alpha x plus beta all over gamma x plus delta plus D times gamma x plus delta. Okay, so we are basically dividing this guy, this smiley mark guy, over star divided by whatever the other guy, heart, divided by the same guy, which is the star. That means smiley mark over star divided by this guy, that means to multiply by the reciprocal, which is the pentagram over hearts. So that means smiley mark, that's going to cancel out. So we're going to have smiley mark over heart. So let's write that down. So we have, this is the smiley mark guy. So we have alpha, A times alpha x plus beta plus B times gamma x plus B delta. We distribute this B, right? We ignore these guys. So, and we have C alpha x plus, this is delta, sorry. No, it's beta, sorry. I was right. So we have C alpha, that's beta. C times C beta, sorry. A times A beta. A times A beta. C times C beta plus B times gamma x plus B delta. So if you just look at the numerator and if you combine like terms, we get A alpha x plus B gamma x. If you use distributive property backwards, you get A alpha plus B gamma x plus A beta plus B delta. All over combined like terms. C alpha x plus B gamma x, using distributive property backwards, we have C beta plus B gamma. So this is R sub A composed of R sub B. So let's look at the right side of it. Do you still remember what we were doing? We are trying to prove that R sub A composed of R sub B is equal to R sub AB. So let's look at R sub AB. If this R sub AB comes out this way, then that means they're equal, so we are happy. So let's look at it. So AB, A times B, that's A, B, C, D times alpha, beta, gamma, delta, which is, remember how to do it? Multiply, multiply, and add, right? So A alpha, B gamma, add them. Here, A beta plus B gamma, B beta, B delta, sorry. C alpha, D gamma, C alpha plus D gamma, C times beta plus D times delta, right? So R sub AB is this X plus this guy, A beta plus B gamma delta, sorry, keep saying delta gamma. C alpha plus D gamma X plus C beta plus D delta. So that's also B. So let's compare this guy to this guy. Take a second to look at it. It's exactly the same after all. So after this, it's the same thing. So that tells us that this guy is exactly the same as this guy, which proved theorem 3.10.